translate the C program, the first C program we wrote in the first exercise session, which calculates the factorial of an integer, but in an iterative way. So we have to translate this to RISC-V. The integer can be provided in the data section, is specified here. So let's look at this code. This is the code from exercise 1, the solution. Where you can see we're going to translate this factorial function. So there is no need to worry yet about this function call. All we gotta do is implement this factorial program. So I realize there's a function call in here, but you can ignore that for now. Function calls are something for the next session. For now, we're simply going to write a program that calculates a factorial using basically the body of this function. So just this code that I've selected is the code we're gonna write. We're not going to write the main function. So first of all, we will have an n value. The n value of what we have to calculate the factorial. We specified n to be equal to 5 as a test value here in our data section. So we reserved the n value in the data section. We reserved one word, 4 bytes, and we stored the value 5 there. And then let's look at this implementation. So remember how this implementation worked. It simply loops. It's a factorial, so you need to get factorial of 5, for example, would be 5 times 4 times 3 times 2. Instead, what we're going to do is 2 times 3 times 4 times 5. Note, there are shorter ways with less registers of writing this. If you did that, very good. But if you didn't, it's perfectly fine to simply translate the C code literally. We can rewrite the C code as well to not use this C variable and to simply use the n variable and subtract that until you reach the value of 2. And then you save on a register and you make this somewhat shorter. But we didn't do this here. So in this solution, in exercise assembly, we are translating literally this code. All right, let's see what happens there. So first of all, we initialized n to some value. And then we loaded that value into T1. So T1 will have the value of n. Then in T0 will be the value of C. So we initialize C here. And in the for loop, C will be initialized to 2. So we initialize C to 2 as well as a preparation for the loop. And then in A0 will be the result. We'll store the result value. That's this long here. So we just use a register to store this long in this case to keep it simple. So we load, this is not maybe entirely accurate because I think the size of a long on RISC-V is probably more than 4 bytes, so it wouldn't really fit in the register. But for now, we don't want to worry about that yet. Just use one register. In this case, we use T0 for the result, A0 for the result register, and we initialize that one to 1. So these 3 first lines initialize res, C, and n. What we now still have to do is write this for loop. What does this for loop do? Well, as long as C is lower than n, it multiplies result by C and increases C by 1. So that's exactly what happens here. If T0 is bigger than T1, if C is bigger than n, sorry, in that case, this for loop is done. So if C is bigger than n, that's the opposite of this condition, then we jump to the end. So we jump to end, and end is the end of our program. If it's not true, if the condition C is smaller than n or equal to n, in that case this branch is not executed, and what we then have to do is execute the body of the for loop. The body of the for loop multiplies the result by C. So multiply result with C and store that result in result again. A0 as result, and it will contain the multiplication of A0 and T0. So that's exactly this line of code. This multiply is exactly this line of code. And then, since this for loop has passed an iteration, we increment C by 1. That's how a for loop works. So we add 1 to T0. And then we simply jump back to the beginning of the for loop. And we check our condition again. We repeat this. And this is how we translated our for loop. So if we assemble this, we can see our our values have been initialized. So in the data section, we have our value of n here, being 5. The end result will be stored in A0. So if we run this program, in A0 should be the end result of 120, which is equal to the faculty of 5.